Okay, in this video, I would like to go over how to find the solution of radical expressions such as this one, using a technique called change of variable. And this video is going to focus specifically on that technique because it's actually a very useful technique that I'm surprised that not everyone actually know about or even have been taught about it. So I'm going to go over it. I'm going to go over it in this case. Well, in this problem, we have square root of 5x plus 1 minus square root of x equal to 5. So the first thing I'm going to do is I'm going to bring the square root of x to the right hand side. And then eventually I'm going to get rid of both of the square root of x. So I'm going to do that by adding square root of x to both sides. On the left hand side, I'm going to be left with square root of 5x plus 1 equal positive square root of x plus 5. Now to get rid of both of these square root, what I'm going to do is I'm going to take the second exponent on both sides. Well, you know that when you have a square root of something and you raise the whole thing to the second power, the square root and the second exponent automatically cancels out. So you're left with 5x plus 1. Equal, well, on the right hand side, you get this thing raised to the second power. That is the same as that thing itself multiplying itself twice, like that. So square root of x plus 5 raised to the second is the same as itself multiplying itself twice. Now, if you FOIL it out, square root of x times square root of x would give you just x. Positive square root of x times positive 5 is going to be 5 times square root of x. And the same thing right here. 5 times square root of x is another 5 plus square root of x. And of course, 5 times 5 is positive 25. Combining like terms by keeping the square root of x and just adding the coefficients, you're going to have x plus 10 times square root of x plus 25. And of course, you bring the left hand side down, which is still going to be 5x plus 1. Okay. Now in this case, what I would recommend is to rewrite the square root of x into its fractional exponent. So that means we're going to have 5x plus 1 equal x plus 10 times x raised to the 1/2 plus 25. Now at this step, you have the x variable on the left and you have some more on the right hand side. Well, you have to decide for yourself, are you going to bring everything to the left or everything to the right? In this case, I'm going to bring everything to the left because what happened is that the highest exponential power in this case is the invisible positive 1, which is optional to write in, but I would recommend that you write it in. Oops, what happened right here? Oh, sorry about that. The battery is running a little low. Well, in this case, the highest exponent is the invisible 1. It is optional to write the exponent 1 in here, but I would recommend that you write it down if it is helpful for you. So I'm going to bring everything to the left-hand side by doing the inverse operation of each of these terms. Meaning I'm going to subtract x to the first, subtract 10 times x raised to the 1/2, subtract 25 from here to here. Well, everything on the right hand side cancels out, so we are left with combining like terms on the left hand side here. Well, 5x to the first minus x to the first is just going to be 4x to the first. We're going to combine that term with the minus 10x to the 1/2, so we keep it as it is. Positive 1 minus 25 is negative 24. Equal, Well, again, everything on the right-hand side is out, so that means it is going to be 0. Now, this is when the change of variable technique comes into place. So in order to use the change of variable technique, you have to notice that there is a constant difference between the exponents. Okay, so just rewrite this a little bit into 4 times x to the first minus 10 times x raised to the 1/2 minus 24. Well, anything by itself, it's the same as the variable. In this case, x raised to the 0 power equals 0. Okay, and this right here is another thing that you should recall at the beginning of this video. Well, if you compare again the exponents, there's a constant difference. Well, to go from 1 to 1/2, you subtract 1/2. And to go from 1/2 to 0, you subtract another 1/2. So because there is a constant difference right here, what you can do is that you can go ahead and now use the change of variable technique. So on the right-hand side, I'm going to write change of variable. Now, what is the change of variable technique? Well, the change of variable technique is a type of technique that allows you to temporarily make your trinomials turn into a standard form quadratic equations, okay? Meaning that your equation is going to temporarily have the degree 2. The difference that you have to notice is that when you use that change of variable technique, your variable would not be x for a little while. It will be another variable of your choice. In this case, I'm going to pick w as my other variable. Okay, so I'm going to let w to the first equal to x raised to the 1/2, which is square root of x. Now, since x raised to the 1/2 is w to the first, what is x to the first in this case then? Well, all you have to do is you take this, play around with that, and you will crank out the replacement of x to the first. So that means if I take x to the 1/2 and I raise it to the second power, that means I'm going to take w to the first and raise it to the second power. Oops, sorry about that. Right here. X to the 1/2 raised to the second is equal to w to the first raised to the second. Now, of course, by the laws of exponent, when you have a variable raised to an exponent and all of it is raised to another one, take the outside exponent, multiply to the inside, and you do the same thing right here. Well, let's see. On the left-hand side, you got 2 multiply 1/2. Well, that's going to turn into 1. So you have x to the first equal, well, 2 times 1 is just 2. So that you got w squared in this case. Well, all you have to do is that you take these two w to the second and to the first, and you respectively replace x to the first and x to the 1/2 on the right-hand side. Okay. So that means I'm going to have 4 times w squared minus 10 times w to the first and then minus 24 equals 0, okay? Now, of course, like I said earlier, anything raised to the 0 is just positive 1, so negative 24 stays the same. Now, in this case, guess what? 4w squared minus 10w to the first minus 24 equals 0. Well, that looks exactly like the standard form of the quadratic equation that you've been searching for, okay? Now, at this step, how do I know whether or not this standard form quadratic equation is factorable or I have to use the quadratic formula? Well, let's see. Let's do some mental math. In this case, I realize that if I take a look at the coefficients there is the greatest common factor of positive 2. So if I bring it out to the front, I'm going to have 2 multiply this whole parentheses equals 0. The inside of the parentheses is going to be the leftover after I factor out a positive 2. So after I factor out a positive 2 from 4w squared, I'm left with just 2w squared. From the negative 10 times w to the first, I got minus 5w. From minus 24, I got minus 12 equals 0. Divide everything by 2. Sorry for my voice, I'm a little sick. Cancel out the 2 on the left. I'm left with 2w squared minus 5w minus 12 equals 0. So if I'm moving the paper out too much, I had to make sure that I can write it properly. Now, is this expression factorable? Well, I'm actually going to play around with it. Okay, I'm going to do some mental math. And this is the way that I've been taught to factor. Or more specifically speaking, this is the way that I find it more comfortable for me to factor, or to try to factor. So if you're okay with using the X method, then go ahead, feel free to use it. If not, then you can try to follow my way of using the mental math here. Well, every time I factor a quadratic expression, I would like to look at the first term, 2w squared, the third term, minus 12, and then the second term, minus 5w. Well, why is that? Well, let's take a look at the first term, 2w squared. The two multiplicative factors of 2w squared is 2w and w. Place it right there. Now, I want to come up with two multiplicative factors of minus 12 such that when I place them in these two empty spaces here, and I FOIL these two binomials back out to see if I'm going to get back this expression. If I do get it back, that means these two binomials multiplying together is the factor form of the left-hand side. Okay, so let's see, two multiplicative factors of minus 12 that I would like to use. It's going to be minus 4, placed right here, and plus 3, placed right there. Well, let's check it real quick on the right-hand side. Okay, so I wonder if you can see that. I'll move it here. Just a quick check. And of course, you can check it mentally too, but hey, when you do math, you want to show your work, okay? The more work you show, the better it is for you to not lose points, okay? Or the less point you lose, I should say. Well, in this case, we have the binomial of 2w plus 3 multiplying w minus 4. Well, if I FOIL these two and I get back the left-hand side over here, then that means this is the factor form of the left-hand side. Well, let's see. Let's FOIL this out. 2w times w, well, that's 2w squared. 2w multiply negative 4 is minus 8w. Positive 3 multiply w is plus 3w. And positive 3 multiply negative 4 is minus 12. And let's combine like terms. Well, when we combine like terms in this case, we realize that 2w squared and minus 12 have to stay there because we cannot do anything with them. Okay? But we can combine like terms, the minus 8w and a plus 3w. Well, why is that? Well, if you recall how to combine like terms back in pre-algebra, you can combine like terms if and only if, one, you have the identical variables, and two, both of these identical variables have identical, or should I say have exactly the same exponents, okay? So we have the variables w and w. They are the same, so that's one check. They also have the same exponents, That's the second check. So combining like terms by keeping w to the first and just adding the coefficients, I'm going to have 2w squared plus, minus 5w to the first minus 12. Well, guess what? This is the same as what we have on the left-hand side. So these two binomials multiplying together is the factor form of the left-hand side right here. So in this case, we can go ahead and use the zero product properties, and we set each of these binomial equal to 0. Okay, so that means I'm going to have 2w plus 3 equals 0, and w minus 4 equals 0. Individually, in each case, you solve for w. Subtract 3, you got w equal negative 3. Divide both sides by 2, you got w equals to 3 minus 2. And the same thing on the case on the left here, plus 4. You got w equal 4.